Now, next topic in this is different types of variables and constant. That is basically a theoretical topic, but you know the things that is more important. Different types of variables and constants. Now, first is dimensional variables. Second is dimensional constants. Third is dimensionless variables. And fourth is dimensionless constants. So from the name itself it is clear what is dimensional variables. Variables, you know, physical quantity that do not have a constant value, that can change. For example, 1, 2, 3 variables. These are variables x, y, z. So there are some variables that have dimensions. For example, area, volume, force, velocity, etc. These are the variables. When you are going to apply a force on mass of 1 kg and you are going to produce an acceleration of 1 meter per second square, then your force is 1 Newton. That is a variable. Now, if suppose mass of an object is 2 kg and acceleration is 2 meter per second square, then your force will be 2 to the 4 Newton. So it is a variable, and force is also having dimensions. That's why dimensional variables. Area, suppose this is a blackboard that is in the form of a rectangle. So this is the length, this is the breadth. Now it will have area, suppose x meter square. Now if suppose I am going to increase the length and decrease the breadth, then what is going to happen? Then area will also change. So variable है और साथ ही साथ dimensions भी है. That's why dimensional variables. Now second is dimensional constants. Constants, you know, that is fixed. Now dimensional constants, right now, before one in last video we have discussed dimensional constant. Constant means that is having a fixed value, and at the same time that constant is having a dimension also, that is your dimensional constant. For example, universal gravitational constant G, that is your dimensional constant. Now for example, speed of light in vacuum, that is also constant, and speed also have dimensions. Now third one is dimensionless variables. Variables, you know, now dimensionless, यानी कि variables that do not have dimensions. For example, इसमें आप क्या ले सकते हो dimensionless variables में? Angle, specific gravity, strain, sin theta, cos theta, etc. Angle we have discussed in this chapter only. Angle is length of an arc upon radius. Angle is length of an arc upon radius. Meter and meter going to cancel, so there will be nothing left. So angle is variable. Yes, angle can have any value, that is 20 degree, 30 degree, 50 degree, 60 degree, 70 degree, any value, but it does not have dimensions. So angle is dimensionless variables. Now fourth one, dimensionless constants. Now what is dimension? A constant, it is a constant but it is not having any dimensions. For example, pi, e, pure numbers, that is 1, 2, 3. In place, if I want to write 1, we can't take any other value. So it is a constant. At the same time, pure numbers doesn't have any dimensions. Now next topic is uses of dimensional analysis. Very important topic. because on the basis of uses of dimensional analysis we have to do some numericals also. Now we have categorized uses of dimensional analysis into three categories. First one, to convert one system to another system. It means conversion of one system into another system. Suppose you are going to convert SI system into CJ system. So first is conversion of one system into another. This is the first one. Second is the checking the correctness of a physical equation. Checking the correctness of physical equation. Any given equation, you can check the correctness. It means you can check whether left hand side is equivalent to right hand side or not. And the fourth one is you can derive the relationship between various physical quantities. To derive the relationship between various physical quantities. Now these are the three things which we will going to discuss one by one. Let's start with the number one, that is conversion of one system of unit into another. Now let's start. First of all, we will derive the relationship for this. Then after that we will do the numericals on this application. How we are going to convert one system of unit into another system. Now suppose we have any physical quantity that we know that we have represented by x, and x is equal to nu. This you know, this we have discussed earlier. X means physical quantity, n means numerical value, u means unit. This you know, you can write it down also. N is number or numerical value, x is physical quantity, pq I have written in short form, u is unit. This is the things. Now suppose we are going to convert from one system into another system. In one system, I suppose M1, L1 and T1 be the fundamental units. Now if suppose I have force in one system, then for that force I suppose M1, L1 and T1 are the fundamental units that is expressed in one system, and N1 be the numerical value in that system, and A, B and C are the respective powers of mass, length and time. मैं लिख लेती हूँ M1, L1 and T1 be the fundamental physical quantities, and N1 be the numerical value, and A, B and C are the respective powers. Are the respective powers of fundamental quantities, that is mass, length and time. Are the respective powers of M1, L1 and T1. This is okay with you? Now if I want to write down this, that is x is a physical quantity. Now I want to write it as a first system. Then what we have supposed in terms of n1 is a numerical value, and M1, L1 and T1 be the fundamental physical quantities. Yani ki these are the units. M is mass, L is length and T is time. So N1 comes out to be M1A, L1B, T1C. C. I hope it is clear to you. We have put these values in this equation. Very simple. Because X is a physical quantity, N is a numerical value, and U is a unit. Yes or no? And this is a general formula. Now I suppose that first system, I don't know which system I am considering. It can be FPS, it can be MKS, it can be CGS, it can be SS system. So in one system, I suppose fundamental quantities are M1, L1 and T1. Yes or no? Fundamental quantities are this. And numerical value is N1, and A, B and C are the respective powers of M1, L1 and T1. Clear? Now, similarly, if I want, this is the first system and I want to convert it into some other system. In that system also, when we are going to convert, X is N2, M2A, L2B, T2C. Now always remember why I have written only X, because physical quantity in both the system will remain the same. The values change. For example, 1 kilometer is a physical quantity in one system now. Yes or no? And physical quantity is length. So in one system it is this, first system it is this. Now if I am going to convert it into second system, length will remain same, but it will 1000 meters. So physical quantity is same. That's why X and X. X is physical quantity in one system. That physical quantity in other system is also X. Length will remain length only. Now these values changes. So here you can say 1 kilometer. N1 is 1 kilometer. So N2, when we are going to convert it into some other system, then what is going to happen? In place of 1, we are having numerical value as 1000. So here it is kilometer, here it is meter. So these are the things. Now how you are going to convert the values, that is the first system into another system. So both are the same. So these two equations must be equal to each other. So N2, M2A, L2B, T2C is equal to N1, M1A, L1B, T1C. Clear? This is C here. So what is the caption? Caption is how you are going to convert one system into another system. So it means you want to convert one system into another system. So what will be the value of N2? N1, M1, M2A, L1, L2B, T1, T2C. So this is your relation for conversion of one system of unit into another system. Thank you.